who are going to be sharing some exciting innovations with you, ranging from how we design urban infrastructure, manage manufacturing practices, and things that will change our food supply chain, as well as even clean energy. So joining us today, we have Andre Kikoski, Joseph Curry, and Alfred Kahn, and we're going to have our panelists introduce themselves, share a bit about their work, dive deeper into the challenges and opportunities that they see on the horizon for the resilient and disruptive technologies that they're working on, and then have some time for some Q&A and closing remarks. So, to start, Andre, you are working on the forefront of what may be the most climate-resilient agriculture complexes that could become the blueprint for future developments. Can you share a bit about those complexes and the most exciting innovations you've seen that you're working on?
Well, yes, thank you. And I guess there are a lot of coulds and shoulds in there, so we'll try to explain a little bit. We have some slides as well. And how do we get those up?
That is a very good question. It doesn't look like my ticker is working. Could we flip to the slides for Andre? Thank you.
Great. So we have been working with our sponsors who have been so generous in making this possible, and we hope you're all enjoying what a great event they put together here at Smart City.
Right.
So we've been working with NEOM for about 3 years, and what you see in front of you is the Oxagon, which is one of 5 NEOM assets, including the very well-known line, Trojena, the ski resort, Sandala Island, which is a island for mega yachts, and this is the Oxagon, which is the future of a port industrial city. I was there at the very start of the project, and it looked nothing like this. It's more like the empty desert side where all of the jebels, the rocky formations, have been scraped flat for our site. And we are at the very top around 11 o'clock, right before the land bridge goes into the floating portion of the city. And so the very first question we had is, how do we build here, and what are we building? Because the challenge was to think about urban agriculture in the desert with a climate sustainable focus, originally intended to produce food for the line. So let's go to the next slide if we could. And we started thinking about how do we approach this with a sense of ingenuity and imagination. Nothing like this has been done before. And I'd come back from this scraped, empty site. My 18-year-old son was sitting with his friends saying, we're all really worried about, will we have fish from the ocean that's not contaminated with plastics? Will there be food? And I was like, guys, we got this, relax. We're gonna figure it out. And that's really the essence of what we had to do. It was about aligning the interests and the expertise of a huge group of scientists, technicians, plant specialists, engineers, architects, with literally a team from all over the world, every part of the country, from America, all the continents, all levels of expertise working together to figure out, first of all, how do we do this? Because anything is possible. We had a huge directive, but then thinking about what is possible, how do we actually do it? So what you're looking at is a rendering of our desert complex. In the forefront is a circular office building meant to be an innovation hub to promote collaboration between all the various entities in the food sector of NEOM. Adjacent to that is a vertical farm. It's the taller rectangular building. Behind that is a 1.5 million square foot greenhouse, which is quite possibly the most sophisticated greenhouse on the planet. It actually has control mechanisms for 7 different greenhouses all folded into one. And of course, there are support structures, ancillary buildings, even an experimental agricultural building. And what you'll see on the next slide is that we are actually fully operational. We're the first NEOM asset that is open in this context. These are lettuces that were, I think, a 6-week germination process, which is fascinating to watch. They are robotically seeded. They move on a conveyor belt into a germination pod. They then go on a mechanized field, if you will. So they start sprouting at one end of this greenhouse, and by the time they get to the end of the greenhouse, they're fully mature. The cartridge that they're in sort of rolls over, and they're harvested. I mean, it's truly spectacular. The technology uses AI sensors to control water, so we're using 93% less water than it's required in a field, and about half of the water required in other hydroponic greenhouses. We use completely clean photovoltaic energy, and it's really just been a sort of marvel of how technology can produce about 4,000 tons of food per year. And we've been really quite pleased to see this happening so efficiently and so quickly.
Absolutely, and as a hydroponicist myself that is working on growing food systems for food security, I know there's an enormous amount of challenges that come with that. Very happy to see this happening. But can you share a bit about those pitfalls that you're running into that you think are important for folks to know when they're integrating food, water, and energy resilience?
Well, one of the guiding principles here is that, dream big and we'll make it happen. And we all approach this very seriously with a lot of rigor in our collaboration. So we opened before the infrastructure was complete. The site work isn't done yet. There's a little bit more work to do on the outside of the building. We've been so successful cultivating our crops that now the question is, where are they going? Originally, they were intended to feed people in the line, and we're ready ahead. So the issue of collaboration and thinking broadly the way that we've had to do it has brought us a level of success that opens up a whole new series of challenges. Like, where does the product go? Who is it going to? Suddenly there are 4,000 tons of food in a place where food isn't produced and distributed. It's 130 degrees out in the middle of August, in the middle of the day, nothing grows there. So who is the wholesaler who's buying our strawberries? Where do we send the tomatoes? It's really a kind of fascinating study in how the infrastructure of food economy works, how the infrastructure of getting water here needs to be really thought through and executed. Unlike New York City, where our sewer system is 100 years old, like, ours isn't even finished yet. So it's a really compelling kind of question about how do you distribute, and when you plan and you are successful at every step of the way, it opens up a whole new series of questions that, well, we hadn't really thought about that yet. Now let's solve it.
For sure, and I will say Andre is being a bit modest because I've heard they've already been growing strawberries, tomatoes, even legumes like beans, my favorites.
Yes.
So definitely excited to see the work continue to grow. Now, moving on, we love intersectional solutions, obviously, when it comes to climate resilience. And Joe, you're working on some really innovative stuff when it comes to advancing LNG cold storage waste recapture, specifically repurposing technologies and methods, and in the process reducing food waste. Can you tell us a bit more about the work that you're doing, how it improves food safety and security, and reduces waste that can power and cool the next generation of cold storage facilities, even potentially AI and data centers?
That's a long sentence.
Yes, sir. You're doing a lot of great work. So.
That was good. So I'm Joe Curry, Chairman and CEO of Orbit Holdings. We're really an entity that's built around solving problems. So we have a very agnostic approach. If you could show the one slide that I brought. This is and I won't bore you with all the details, but what you're looking at is, it's not just an image. This is the largest and most energy efficient, sustainable cold storage facilities in the world. This is in South Korea. It's run 100% by renewable energy. We capture the LNG cold energy waste at LNG import terminals, and we use that cold energy to power this 1.7 million square foot facility in South Korea. The dynamics around agriculture and food and things that Andre's touched on and Al will is you can't really talk about these things without understanding food waste. Food waste is the 800-pound gorilla that is impacting vertically all of these systems. So our desire with this initially was to address the food waste in South Korea. That was quite substantial. And in order to do that, we needed to address the energy. So we have found, we're the only ones in the world that do this. We found a way to harness the cold energy that's wasted at LNG import terminals, and then we've captured it and repurposed it. The cheapest energy in the world, cheaper than solar, cheaper than nuclear and geothermal and all the others, is energy that people are paying for at scale and wasting at scale. All in, there's about 131 terawatts of energy that's being wasted every year in the LNG value chain. That's enough energy to power 50% of all the American homes for 1 year. So being able to capture that and reuse it is very vitally important. When you talk about some of the dynamics around agriculture, this will kind of give you an idea of what we can do and what we're trying to do. You look at a place like India that has about 10 LNG import terminals, obviously has environmental, ocean health issues, but they have about 200 million people that are defined as starving by the UN. They are the second largest producer of food in the world behind China, but they waste about 40% of all the food they produce. So being able to capture that cold energy that's being wasted at those LNG import terminals, using that to innovate their cold storage and cold logistics, helping to reduce food waste, ocean harm, and the like, and then being able to feed people that need food. So we're really excited about what we're doing, and we're applying this to data centers and other applications.
And if I may, for anybody that watches Shark Tank, you see notoriously Kevin Leary and Mark Cuban turn down opportunities when it comes to food businesses, especially cold food businesses, because of the challenges with cold storage. So I do want to have you share a bit about that. What are some of the biggest challenges, or the biggest challenge that you see with implementing this unique solution at scale?
I don't really see too many. The world is, obviously everyone knows the dynamics around energy and energy insecurity. Everyone knows about the COP commitments and UN SDG and all the other commitments, but no one knows really how to achieve them. We're kind of looking for one-off solutions that don't incorporate all the different dynamics. You can't solve food waste if you don't solve energy insecurity. You can't solve overfishing if you don't solve energy insecurity. So the biggest challenge, I think, is time. I just, hope there's enough time.
There definitely will be, I hope. All right, now, Al, you've worn so many hats over the years, and for folks who may not already know, previously, folks knew you from bringing Pokemon to the US, which I'm so grateful for. Pokemon Go is my favorite hobby. But now you are revolutionizing and minifying manufacturing through 2D printing. Can you please elaborate on the work that Vitprints is doing with milk printing technology and how it's reducing water waste?
I'm going to get my microphone on.
We can switch if you need to.
Well, thank you very much for having me. I'm really delighted. This is such a difference for me. I'm usually in the middle of a toy fair, so this is like wow, this is like where real people are. Actually, and there's not a lot of little kids running around, which is kind of interesting. I've started a company with a couple of my partners, which is called Vitprints, and we took an idea that was a toy 30 years ago. 30 years ago, we got the idea of could we print things that were three-dimensional and make them flat. Now this sounds like today everybody does that, but 30 years ago no one was doing it. And we created the first ink that actually conducted electricity. So we had kids who could draw on a train station, they could draw a track, we put a little battery clip on it, and the train would run on that piece of paper. Well, we started to look at that more and more and said to ourselves, what else could we print? Well, and now I'm happy to say we hit the jackpot. We are now printing milk. And I want to talk about how we do it and why we do it. First of all, the shipping cost of liquids are high, as you know. Number two, the need to refrigerate. Our product does not require refrigeration. We had consistent product quality to the multiple ingredients in milk. For instance, in oat milk, if you look at the label, there's probably 30 different variables in terms of what's inside that container of oat milk because to keep it from spoiling while it's not being used. Also, short shelf life. In other words, when you buy a container of oat milk, you have a certain amount of time that oat milk is still good. Packaging. Everything is in plastic packaging or in metal, or not metal, or in glass packaging. We don't use any packaging except paper. I'm going to show you the next slide, if you don't mind. This is the, can you push the next slide
Next
for me?
slide.
Is there another slide? No? Okay, well, I'll have to wing it myself. This is 2 gallons of oat milk. It's in a plastic package. Pardon me? Okay, there's 2 gallons of oat milk that are in a plastic package that is used because everything we do is we remove everything from the product, including the water. Most products today on the market are 85 to 90% water. If you look at the packaging on anything like milks or like Gatorade or like anything like that, you actually realize that most of it is water. We remove the water and we keep the essence of that particular product, and we make form factors, which are actual printed discs that enable us to create the actual similar product without having the milk, without having the water, without having the waste. When the consumer buys this product, all they do is reconstitute it with water, and it becomes the best tasting, freshest, most desirable milk on the planet. We've been in Europe now for about a year. It has revolutionized the European market. Every supermarket in Europe is carrying our product, and that now we are launching in the United States. But this is only the beginning of what this technology can do. So I think we are standing on the cusp of, I believe, the Pokemon of technology. Which wouldn't be a bad thing, right? You know, I think about that. Pokemon today is worth about $125 billion. I think this is bigger. Because this goes into every category you could possibly imagine. We're also printing now vitamins. We're printing vitamins for dogs, because dogs don't like to take pills. We're printing all kinds of material that we can get rid of packaging completely. And I think that's the key element, sustainability. Every major company that makes products have come to us under non-disclosure agreements, and we are working with all the majors to create a way of doing things that has never been seen before, whether in the supermarket or at home.
Absolutely. And can I ask, what are some of the challenges that you're seeing with scaling that work?
One of our new stuff? Ooh, our challenge, well, there's a big challenge. We can't make it fast enough. Yeah. We have to build plants. This is a 2D printing process, and our biggest problem is everybody comes to us and says, can you do this? And we then go to our lab, we make a model of what we can do, and they go, great, we'll take it. Well, we can't make it. So our biggest problem right now is management, is obviously command and control, but also protecting our IP, but also building plants, because I don't want to license this like we did with my other products. I want to manufacture these things so we protect the secret sauce, if you will. But we are printing Parma, we printed vitamins, we can print, you'll love this one. This is one of my favorites. We did this to show it to Walmart. Walmart every week runs these wonderful sales, right? And they have cardboard sale signs, and what do they do with the sign after the week is out? They have to throw them into a landfill. You know that most landfills are filled with paper. We created a new paper called Napper. Napper is a paper that is basically organic paper, and we print the way we print milks. So with a Walmart, for instance, they can print a sign, and then when that sign is completed, that paper gets dropped into water, and it turns into their cleaning liquid. So they can clean their stores. The paper evaporates and leaves behind only the stuff that they use to clean the stores. Those are the kinds of craziness this thing is evolving to. And when I sit back and look at the lab every day, and I go, wow, that's pretty good. And and again, it's amazing. It's amazing. And I think it's only to our imagination will this thing be. We've identified already 60 categories where this process will work dramatically well, and that we're just looking for, again, funding. We're looking for more money. We're looking for more, obviously, ability to build plants. And then, obviously, we will, because the orders are there. We get the orders. The orders are coming in, but we just don't have, right now, the infrastructure. This is relatively new.
I was really wishing that we would have Vitprints on the bottom of everybody's table or chairs to pull them out right now. But no worries. So our audience is filled with technologists, futurists, people who care about building a more advanced, sustainable future. And I'd like to get just an insight, a takeaway, or an actionable step that you guys think are really important for folks to consider in this journey as they try to contribute to a more sustainable future. Andre, do you want to kick us off?
Well, our focus on food security was really trying to solve for future generations to make sure that as the inevitable warming of our planet happens, as our climate changes, there is a way to produce food for masses in places where it doesn't grow. We had to look at ancient principles of the greenhouse, which actually dates back to 1450, first instance actually in Korea, and then with a collaborative embrace of various kinds of expertise, really come up with an innovation that was driven by collaboration more so than technology. There were myriad choices to make, but understanding at every level the incredible nuance that each team member contributed was essential. For instance, you would think, great, you have a greenhouse, you have your crops, grow them. Who knew that a certain variety of strawberry does not grow with desalinated ocean water? I mean, the level of, it was a little bit like this morning's speech about planning the Paris Olympics, like massive levels of expertise required from a diverse group of people to take an old idea and make it salient for future generations. So I think that collaboration is key.
Thank you. Joseph, please, if you don't mind sharing a takeaway or insight.
I would say the common theme with Andre, Al, and myself is relatively would look to be simple and obvious solutions. A lot of times people are waiting for some new technology and some new ideology that's going to save the world and create economics, et cetera, et cetera. I think there are a lot of things that are very simple that we see that we could do individually and collectively. And if we don't do them, shame on us. But the solutions are there. It's just a matter of working together and collaborating, having kind of an open dialogue and trying to solve problems. But the solutions exist. It's up to us to find and deploy them.
And Al, definitely last but not least. Is the mic being funny again?
The world is a crazy place. Don't we know it? And that there are so many places where our technology would be appropriate. For instance, we can make COVID vaccine that doesn't require refrigeration. We can print it. Can you imagine how much that would help if a pandemic in countries that don't have refrigeration? Joe, I said to Joe, I want to put him out of business. I want to be but I mean that. I want to make that very. It's a joke. No, it's not. Okay, but the bottom line story is we are sitting on a cusp of something that is incredible. I'm a firm believer in children. My whole life has been children. And what universe are we going to leave the children? Are we going to leave them a universe that is just full of cans and plastic and all the other things that are demonstrably bad for them? Or are we going to leave them in a world where we are going to remove those plastics, we're going to remove those bottles and cans, we're going to save water. We're going to save water. We're going to save all the things that we need to do. That's my desire. That's the reason why I do this. I don't do it because, you know, there may be some money in it. I don't know. I have a foundation that gets the money, so I don't even know. But what I do know is that I can't stand what's going on with children today. I can't stand it. And I cannot sit back and watch this thing keep on. That's why everybody on the stage are heroes to me. They're much smarter than I am. What I'm good at is bullshit. That's what I'm really good at. Okay, and I can sell you your car. But the bottom line story is, I really believe in what we do, and I believe that we can create something that would create sustainability on a global basis, but also make sure that the planet is ripe for our next generations and the generations after.
Thank you for sharing, Al. And I think that what you're doing is amazing. Big hand for our panelists. Thank you. I think we have time for 1 or 2 questions if any folks want to ask really briefly. You might need to project. Yeah, go for it.
Question for Joe. Could you just break down the process of how you use the ocean, for example, to cool cooling centers? I don't know that everybody understands that.
Sure. So I'll give everyone a 30-second tutorial on natural gas. So natural gas and LNG are essentially one and the same thing. It's the only distinction is natural gas is undergone being put under a coolant of minus 260 degrees. That condenses it to 1/600th of its size, but it's super cold. Allows you, instead of putting and shipping LNG using 600 tankers, you can use 1 tanker, right? So it's super efficient. The problem is that when governments buy this LNG, it's not really the LNG they want, it's the NG, it's the natural gas. So you have to reverse that process. And when you reverse that process, you use ocean water to warm and separate the the liquefaction component, from the natural gas. That cold component, if you're someone who's in the audience and you care about oceans, and you care about ocean and fish health and marine biology, minus 260 degrees of cold energy hitting the oceans, it kills everything within a 5-kilometer distance. It's very harmful to ocean life. So what we do is we capture the L before it hits the ocean. We then take the the cold energy component ourselves, and we simply reuse it. On the surface, it's a very simple business.
It's LNG 101. We have a question in the back, if you don't mind projecting. Anybody working on localized projects?
Well, the idea is that this is a blueprint for the future, and the question of how something like this could be replicated into other parts of the world. I mean, food security is a huge issue in all the Gulf countries, not just Saudi Arabia, for obvious reasons about what's happening with warming temperatures there. We're very interested in exploring the rollout of this technology and the idea that it could be combined with cold storage, and maybe we could 3D print some spinach or something.
That's not fair. It's 2 against 1 now, right? So the bottom line is we are having everything we do, of course, when it comes to foods, goes to the FDA. So our licensees have to pass the FDA, qualifications. Of course, I don't know what those are now with the new head of the FDA. I think they can't be vaccines, is what I think it can't be. But the bottom line story is, what's amazing to me, all the countries around the world want this. China, we have a huge opportunity in China. China can't make enough milk in China. because there's so much problems with it. And so we are going to be, it's not done yet, we're going to open plants in the United States that's going to ship milk to China. So we're going to do the reverse tariff, reverse tariff thing. But so we know that we want to be apolitical to the extent that we can, obviously. But by the same token, we know that we've hit a nerve. And this nerve, the UN has reached out to us. We've gotten so many people who have really tried to really figure out what the heck is this thing? It's really not that dramatically crazy. But the idea is we have a tremendous amount of patents that are pending, that hopefully, but again, we all know that patents are patents. So our job is to get this up and running as quick as we can and make sure we become the brand that is demonstrable in this particular area.
Joseph, did you want to share any ideas on localizing the work you do?
For us, the secret sauce is being where liquefied natural gas is being imported. The United States, Qatar, Australia, these are obviously major exporters. So we need to be where there's 53 countries right now that import LNG, and that represents about 195 LNG import terminals. So our real opportunities are obviously overseas, Europe, Asia, Latin America, the United States, and sadly, the entire continent of Africa are not really ideal for what we do because there's no LNG import terminals.
Gotcha. And if anybody is curious about building hydroponic systems in New York City, feel free to check out my organization, Change Food for Good. Little plug. But that is it for our panelists. You're welcome to stick around and ask more questions if you like. Thank you so much to everybody, Andre, Joseph, Al. We appreciate your insights and your knowledge. And thank you again.